Perfect square numbers. These are a special set of numbers. The smallest perfect square is going to be 0 because 0 squared is 0. Or think of it as what number squared give you 0? Well, 0. The next perfect square is 1, followed by 4, followed by 9, followed by 16. These are special numbers because 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, 64, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squares 196, and so on and so forth. So we wrote down the first 14 perfect squares. How did we find perfect squares? Take the number 0 square, take the number 1 square, take the number 2 square, take the number 3 square, and so on and so forth. So perfect squares are needed because our next concept is how to find the square root of a number. So we say that 4 is the square root of 16 because 4 square gives you 16. By definition, c is the square root of the number c square. So whatever c square turns out to be, c is the square root of it. Every positive number has 2 square roots. 0 has 1 square root. Negative numbers do not have any square roots. Find the square root of 49. So ask yourself, what number squared give you 49? Turns out that 7 and also negative 7. Find the square root of 64. So what number squared give you 64? Well, that's 8 and also negative 8. Whenever we refer to the square root of a number, we mean the non-negative square root of that number. That is often referred to as the principal square root of the number. What this means is when we are, most of the time when we're trying to find the square root of a number, we only look for the positive answers. Alright, so from now on, if you're looking for the square root, only give positive answer. If you see the symbols, this symbols tells you that we only want the principal roots, which means that we only want the positive answers. So this symbol tells us what is the square root of 81, and that's 9. Because 9 squared is 81. So what number square give you 81? 9. The square root of 36? 6. The square root of 49? 7, with an extra negative in the front. The square root of negative 9. What number squared give you negative 9? None. The square root of 4 over 25, that's 2 over 5, because 2 squares is 4, 5 squares is 25. Okay, so some properties of square roots that you should keep in mind. Whenever you square a radical, you get the number below the radical. We call this the radicand. Okay? When you take the square root of b squared, then you actually get the absolute value of b. So there's a difference. If the square is global, if the square is outer, then you get b. But if the square is inside, you're squaring the b, then you actually get absolute value of b. So remember this statement. This is one that you will often forget. Okay, so let's apply that to two properties. When we square globally, we get the number inside, so this is negative 3. When we square the inside, so the square root of negative 3 squared, we get the absolute value of negative 3, and that equals 2 to 3. So that's a difference. The square root of 36 squared, that's the absolute value of 36, which is 36. The square root of 16x squared, that's going to be, the square root of 16 is going to be 4. And then the square root of x is going to be absolute value of x, because that is part of the second property that we put a star around. The square root of x to the 12. So what we want to do is we want to write it like this. X to the 12 is the same as x to the 6 squared, right? and therefore this becomes the absolute value of x to the 6, which equals to x to the 6. Because x to the 6 is automatically going to be a positive number, therefore there's no need to put an absolute value around it. The square root of m to the 10, m to the 5 square, which equals to m to the 5, and we have to leave the absolute value around it because this is raised to an odd power, so it's possible that this could be a negative number. The square root of y plus 3 square, that equals to the absolute value of y plus 3, like that. This is using the second property, so you have to keep that in mind because that's something that you often will make mistakes on. Cube root. Similar to square root, cube root is 3 is the cube root of 27 because 3 cubed equals to 27. By definition, we say that a number is the cube root of, we say that c is the cube root of the number c cube. Here's what we know about cube roots. Every number, positive or negative, has just one cube root. So what's the cube root of 16? Find the number such that when you cube it, you get 16. And there isn't any. So let's change this to 64. Okay. So find the cube root of 64. Well, we know that 4 cubed is 64. So the cube root of 64 is going to be 4. Find the cube root of 8. We know that negative 2 raised to the third gives you negative 8. Therefore, the cube root of negative 8 is negative 2. Find the cube root of 10 to the third. So to find the cube root of 10 to the third, what we can do is we can go the cube root of 10 to the second cube. And then because this got raised to the third power, according to this rule, the number, that c value, whatever got cubed, is the root. So in this case, we know that the number that got cubed is 10 squared, or 100. Alright, so properties of cube roots, not similar to square roots, but property of cube roots is a little bit different, but yeah, kind of similar to square roots. When you raise a cube root to the third power, globally, then you just get the number inside the root. When the number inside the root is raised to the third power, then it's also that value. So just a little bit similar to square root for the first part, but the second part is a little bit different. All right, let's apply these two properties for cube root to some of these problems. So this looks like it's similar to property number 2, the second property. So therefore we get 10 because 10 got cubed. All right, so this looks exactly like property A, so therefore we get negative 5. Now this one is negative 1 is special, and so when you have negative 1 to the fourth root, and by the way, I added on more power because we can apply the same concept of like cube root, square root, and fourth root. So basically what this means is I'm looking for a number such that when I multiply it 4 times, what number such that when you multiply itself 4 times, you get negative 1? Or what number such that when you raise to the fourth power, you get negative 1? And here's the thing, if you raise any number to the fourth power, it should be a positive number, and therefore, this one does not exist. The fifth root of negative 32. So what number raised to the fifth power gives you 32? And it turns out that 2 to the fifth power is 32. It's negative 32, and therefore the answer to this problem is negative 2. The fourth root of 16r to the 8s to the fourth. Now for this problem, because we're dealing with the fourth root, what you want to do is you want to rewrite these problems so that it has a 4 as the power. So we can write r8 as r squared to the 4. r squared to the 4. And then this one is just s to the 4. So anything that has a fourth power, you can take that out of the radical. So therefore you have 2, you can take 2 out. You can also take an r squared out, and also you can take an s out, according to the rule. And then number 13 over here, the fourth root of m plus 4 to the 8th power. So what you want to do here is you want to manipulate this so that it says m to the 4th to the square and then to the 4th, so that these two matches up, which now is applicable to the property of fourth root, which means that you can take out an m plus 4 square because these two are the same. Alright, the last thing we want to do is we want to look at radical as a function. So what are functions? Functions have inputs, and then input gets put into a function, and then that function will have an output. Okay? So when you see this statement right here, it's asking you for the output when the input is 5. So what you do, you plug 5 in here for the letter x, and then you state what the output is. This becomes the square root of 9, and the square root of 9 is 3. Now, this might be the first time we talk about domain, but domain consists of x values that is acceptable for the function. And what I mean by acceptable for the function is that you can actually plug it into the function. So to find the domain, the easiest way to find the domain is to find the numbers that you really can't plug into the function. So if you recall what we talk about radicals, or what we talk about the square root. Square root are defined only if the numbers in it, now the number in it is called the radicand. It's only defined when the radicand is positive, is 0 or larger, or we say positive, okay, including 0. So what we do to find the domain is we look for numbers that are not allowed to go in here. And what we do is we go, okay, so any number, so this value right here must be a number that's larger than or equal to 0. And if we solve this inequality, then we subtract 4 to both sides, and we're going to get x is greater than -4. So that tells us that any number that's greater than or equal to -4 will make this statement either 0 or positive, which has an output. So domain is defined to be your input, your possible input. So your possible inputs are going to be x, such that it has to be the number that is larger than or equal to -4.